Okay guys, I have a simplified version of two cars. The two cars have the exact same mass. One has had a little more than half the wood removed and a steel weight added in the back. That makes for a much different center of mass. If I take a look at the center of mass is pretty much dead center of this wood block. Here, by placing the steel in the very back, the center of mass has moved from the zero line back 1.6 inches. Concentrating the weight back moves the center more than 1.5 inches back. When I place it on a track at a 26-degree angle, you can see the center of mass is now higher. The center of mass is, in this scenario, 2.072 inches above the starting point of the bottom of the car, and here it is 2.798 inches above the starting point, the bottom front of the car. So I picked up about 3/4 of an inch higher in this scenario. As that races down the track, it's going to result in a larger drop. There will be more potential energy converted to kinetic energy, so that when I come out of the bottom here and run this straight section, the car with the steel weight will be running faster. When I get to the bottom, I'm going to have less than a car length lead with the steel. Essentially, we're going to treat that as negligible. There's still 21 feet of flat track to go. That's where they're going to have the different speeds. To figure out the difference of speed, I need to look at the conservation of energy. So the conservation of energy simply states that if energy is conserved, which it is for the most part, ignoring friction, which sometimes we do in physics, potential energy is going to translate into kinetic energy. As the potential leaves, that means it gets lower and lower, the kinetic energy will grow. The formulas for potential energy in this situation are mass times gravity times the change in height, and the formula for kinetic energy is 1/2 mass times the change in velocity squared. Since the initial velocity is 0, the change is it's all one addition, and since the change in height, we treat that as it goes to a 0, that's also one number. Working through it mathematically, I can cancel my m's out. There's one on each side, so I would just divide by m in algebra class, and then I end up with GH equals 1/2 v squared. I would multiply by 2 to get rid of that 1/2, and I would have 2GH equal 2v squared. Please note I'm not saying delta. I would then take the square root of both sides, and I would get the square root of 2GH equals v. Substituting in for gravity, because we're on Earth, I use 32 feet per second squared. A lot of times in science class you probably use 9.81 meters per second squared. 9.8 meters is 32 feet. And then for the change in height, that was that 0.726 inches. I had to change that to feet so that everything lines up and make sure I use good dimensional analysis. That's going to be 0.06. When I plug those in and take the square root, I ended up with 1.97 feet per second for my difference in velocity. If it takes approximately a second to run that last 21 feet of the track, and one is going 1.9 feet per second faster, understand it's going to win by 1.9 feet, because it's in that second, that's how much farther it's going to travel. So that is several car lengths, and this is why the conservation of energy is one of the key hacks to being successful in that. It all goes back to the idea that we want to change our center of mass. We want to move it back because it starts off on an angled track. By moving it back, we have moved the weight higher. Drop something from a higher distance and it will be traveling faster when it hits the ground. All right, good luck.